Right, hello everyone and welcome to the midas GTS NX presentation. So we're going to be looking at the 3D geotechnical finite element modelling and analysis with the newest technology of midas GTS NX. My name's Adam Kane, I'm one of the technical support engineers, and the details for our UK support and also the telephone number are on screen. Just going to go straight into it and make a start. So just quickly give you a brief overview of using GoToWebinar. So first of all, I know that you can hear me because we've had a test beforehand to make sure that everybody can hear us in the room. If you can also see my screen, if you want to maximize the screen, just click on the two overlaying boxes in the top right hand corner. If your screensaver happens to kick in, your screen goes blank, then you will have to set that to off, or you can just simply wiggle the mouse. A few more GoToWebinar meeting requests or just instructions. If you click the red arrow, then it will minimize to a slim strip. You can ask questions in the chat box, and we do have one of our technical support engineers on standby to answer them as they come in. Just to give you a brief introduction to Midas. Midas are a world-leading engineering software solution developer and distributor. We've got the #1 market share in terms of civil engineering software solutions, and we have over 450 engineers and professionals working for the company. We distribute in 120 countries, and we have 10,000 clients, and we've sold over 30,000 licenses, making us a global award-winning company. Okay, so this is our global network. If you see on the screen, we do have support offices all over the world. So in the UK, we do have it in Hammersmith in London. We also have them in America and going across the world, so that means your support is also worldwide. We've got partners distributing to all the 120 countries as well. So we do provide the complete software solution package. So just to go through, we do the building and structural engineering in the form of midas Gen. We do the bridges and civil engineering in terms of midas Civil, and we also do high-end advanced nonlinear analysis in the form of midas FEA. We do the geotechnical and tunneling engineering in the form of 3D finite element analysis software midas GTS NX, and we also do 2D finite element analysis software in the form of SoilWorks. We also even do the mechanical engineering software for moving components, such as stress analysis and things like that. We do provide free training. We support you through live projects, so we can come into your office and provide you with the training in-house on a live project that you have running. We also do, as we did last year, we have webinars that are scheduled and they're interactive, but we can also customize them. So if you do have any requests on things you'd like to see, then please send those requests in and we will go through them with you. So just to go through some of the application areas and key things to focus on within industry. So we can do the piled raft modelling and nonlinear pile soil interactions, key for in-city areas, so we can see the reactions on other buildings and tunnels and things like that. We can do the excavation supported with temporary or permanent structures, so another key one for excavations and construction stages. Complex tunnel intersections such as the Y-type, T-type portals and launch shafts. Obviously, in the UK at the moment, we're using a lot of tunnel boring machines, and we're doing a lot of excavation works and extensions to tube lines and tube extensions as well, as long as stations extensions. We do the shield tunnel boring with excavation sequences and construction stages, making it key for using in underground structures. So a few more product application areas. So a key thing for high speed 2 and the vibration analysis due to moving train loads. You can automatically generate dynamic functions and simulate the passage of a train's axles with time going over the embankment. We can do the modelling of station boxes and underground caverns. So another one, such as just an example, Tottenham Court Road extension and different extensions around London that have been application areas that are being simulated at the moment. The groundwater analysis for seepage flow in earth dams and the effects of cut-off walls and clay cores. Another key one for the water industry is because we're having our contracts coming up now in the UK in 2014, sorry. We do slope stability, including the reinforcements and the challenge of water levels due to precipitations, and obviously with all the slippage that are happening in the UK as well at the moment, with the bad weather we've had over the last couple of years, especially 2012 and 2013 for that matter, over the Christmas period leading up to 2014, it's a key thing that we need to focus on. So just taking you into midas GTS and give you a brief overview. So those were some of the project applications, and we're going to show you an overview of how midas GTS NX can actually simulate these and go through the problem areas in the projects. So first of all, I'll give you an overview, and so just to talk about midas GTS NX. So it's a robust, easy to use 3D finite element software which integrates the pre and post processor and solver for modelling and analysis of complex soil structure interaction and poor water pressure problems. The capabilities of NX include construction stages, groundwater flow for saturated and unsaturated soils, including the suction, nonlinear, the slope stability, dynamic analysis for earthquake and vibrations as well. So it's a convenient, fast, accurate and productive tool to use for your 3D finite element analysis problems. So the configuration, you have the CAD-based geometry modeler, and you can bring in anything from or import anything from a CAD-based system straight into the program. We've got the automatic mesh generation. You can set how fine you want the mesh to be. We've got the pre-processor, and that's basically for the loads and boundary conditions and also construction stages. We've got the solver at the end, so your post-processing, going through to your analysis extraction, your post-processor with your results extraction as well. And also we have the data generation at the end, where you can create tables and graphical representations of your modelling space. So just go into geometry modelling. So just looking at curve modelling, so multi-CAD based features to generate non-regular complex 2D and 3D geometry and sections. So NX also has built-in templates to generate tunnel cross sections quickly, along with definition of rock bolts where the elements are built into the wizards for ease of selection. And we've got different curve types and lines and arches, circles, ellipses, everything like that, so you can draw up the model quickly and easily. So for the surface modelling, we can create highly irregular 3D surfaces representing axial ground topography and stratigraphy. This can be created within GTS from input data from other sources. Your input data could be used in terms of spatial coordinates or geometry edges. For the borehole data, which can be easily imported into GTS NX for generation of 3D ground layers. This can be done from point-based borehole data, where NX then automatically generates the interconnecting surfaces by interpolation, as you can see on the slide here. So just a multitude of different boreholes set on different levels, and then it creates the topography of the ground, and then you can create your meshes from that, your solids. So for solid modelling, you can either use predefined solid shapes to create volumes, or build up your own using 2D geometry features. So solids and other geometry entries such as surfaces or edges can be automatically combined. So operations such as Boolean, dividing solid volumes for construction stages, or generating ground layers. So for the advanced modelling, you can use our vast library of CAD functions. 3D geometry can be easily generated from 2D geometry by operations like extrusion, revolution with respect to an axis, or sweeping with respect to a guide curve. For exchange, you can import geometry from commercial CAD software, as I previously mentioned. It's got a robust options, mean that no data in terms of edges or surfaces are lost during the import operation. And once the geometry is imported, there are a variety of different tools to fix geometry shapes. For example, where you have gaps between edges that could not be connected, i.e. where the CAD draftsman missed it or separated the edges and he hasn't connected them properly. NX can basically remove these and create the gap between the two, so you can create your surfaces and create your meshes and things like that. Geometry and mesh data in terms of nodes and element tables can also be imported as well and exported. So the terrain geometry maker, built-in features to generate 3D topography by automatically extracting contour profiles from CAD files. So as you can see on the screen, this is a digital map that's been taken from CAD, and then you can actually, it's a DXF data, and you can create an actual surface from that, and then extruding it into the actual topography and creating a mesh from it. So now I'm going to take you over to the GUI of NX and just show you some of the different modelling features and also the different views and everything like that, just to take you around the workspace. So this is the it's the ribbon technology at the top of the screen. So it's all easily set out. So you've got geometry, and then you can go through your meshes, static and slope analysis, seepage and consolidation, and then take you all the way through to dynamic analysis. We can import different file formats, so there's all your CAD based and DXF and everything like that. We can also do the export as well, so just showing you a few of the export options. Just to take you through some of the meshes, so just to show you them and display them, we can also isolate any mesh and we can hide all. So just to open up the mesh and just to highlight one of them. So that's the geometry, and you can visualize the geometry quite easily and effectively and manipulate it by moving it around the screen. So just flicking it around there. You can set different viewpoints, you can look at different wireframes and shadings and lines. So just flick it on lines, you can see the piles at the bottom of the structure. You can also just hide different layers as well, so just by selecting them you can hide them, just to make sure that it's really easy to manipulate and work your way around the working space. So as you can see, you've just got the template at the end, you've actually got the construction of the piles, the foundations, the abutment and also the embankment. So just look at the geometry again, just to show all, and just select it so it's shading. And then what we're going to do now is, so that was just give you a brief overview of the working space. We'll come back to it later on in the presentation, just to show you a bit more. So just now back to the actual presentation itself and take you through the mesh generation. So just look at the auto mesh generation. You can generate mesh automatically for any complex geometry. Intersecting volumes using auto mesh feature. You can either use tetrahedral elements or for smoother calculation of stress and pore water pressures at nodal points. You can generate combinations of elements in your model using heterahedral, pentahedral and tetrahedral elements. So you can use either linear or quadratic elements as well, as you can see. So for the map mesh generation, on the other hand, if the model was symmetric or permits generation of structural mesh, you can use the map mesh feature to generate structured or regular mesh either in 2D or 3D geometries. So as you see the lining of the tunnel there and the connection between the tunnel. You can also look at the abutment as well, where it's fully meshed, and we can even do offset functions and things like that. So just look at the map mesh protrusion. So we can take a 2D surface or a 2D mesh and then manipulate it into a 3D mesh, and also do all the tunnel linings and everything like that. So the solid map mesh generates hetra and or petra mesh in simple solids by full mapping or combined auto plus map. You can also do clip views, which I'll show you in the working space in a minute, but you can clip through any part of the geometry just by selecting it from any angle as well. So for the protrusion, we can, so similar to the geometry functions, 2D mesh can be used to generate 3D mesh easily. Using the mesh protrusion functions such as uniform or non-uniform, extrusion and revolution, and other functions such as that. So we've also got the fill function as well, you can see in the top right hand corner, and just extrude by a line. So for the size control, NX provides automatic and manual operation control of the size of the elements in your model. You can define edges or global seas to restrict the element size at areas of stress concentration. So here you can see the tunnel shaft and the concentration of the mesh moving towards the center and the actual tunnel. So it's a more refined, finer mesh, so you can gain more accurate results. So it provides various size control methods: uniform size, division, linear grading, size and ratio and symmetric options, and hyperbolic, tangent and refinement options as well. So it's a uniform size, and you can look at the linear grading from the outside as well, so you can actually set it. And we can also refine the mesh from being a fine mesh to normal to a coarse mesh as well, as you see that in the sample in the bottom right hand corner. So just looking at the 64-bit processor, NX geometry kernel is based on a parasolid kernel, and within 64-bit pre and post processor. You can easily generate and manipulate large model sizes with 500 to 600 solid volumes and millions of different elements as well. And even more, you can actually, it can handle huge models, and the solvers can solve it very fast. So we've got the multi-thread parallel mesh generation feature, which optimizes the mesh generation using the best combination of your hardware resources. So it really does use all the computer power you've got available. So just going back into the working space and looking at some of that mesh generation and different things like that. So just to show you geometry and then turn on the mesh. I just want to do some different selection processes as well, and also clip-in planes through this. So if you just bear with me, you can see all the actual different mesh sets with the weathered rock and embankments and all the different types of materials that we've got available. You can click on them and it will connect to the model, but you can see the weathered soil there and also the soft rock, and you can see it connecting to the model as well. So just to show you the clipping plane, this is just a simple function where you can drag, reverse it and then drag it either way. So I'm just going to drag that, and as you can see, you can look through the mesh. So we can add those different clip-in planes as well and save them, so you can do a multitude on the same one. So back to the original view, and we can look at different elements, and just to iterate how we can just select an area. So just going to quickly select an area just at random, and we can isolate that and just show it. So as you can see, we can do that at any angle as well, and it doesn't matter about the complex geometry, shape or anything like that. So as you see straight through the mesh. And look at the foundation of the abutment and the embankment as well. So, and we can also just show different modes or isolate it, show it in wireframe when it's on a different mesh set. So looking at different wireframes and different features, so you can look at different ways of selecting it, so different material selections, and you can actually manipulate it so you can look at all the material colour along all of the different layers. So now I'm just going to take you back into the presentation, just flick on all the mesh sets again and take it back to the original view. We'll come back to the model in a moment. Just want to take you back to the presentation briefly and go through the analysis and different wizards that we provide. So GTS comes loaded with a multitude of analysis options, as you can visualize on the screen there. You can perform elastoplastic, drained or undrained, staggered, coupled and full coupled, stress-seepage analysis based on excess or total poor water pressures, strength reduction method and stress analysis method, analysis for the auto calculation of factors of safety for the slope stability problems. You can also do the earthquake and vibration analysis through linear and non-linear time history analysis. So we've got a library of different available element types. So as it is finite element based, and we do have an extensive list. So you've got different line types there in the form of truss beam, tension only, compression only, where you can manipulate your ground anchors and your rock bolts and things like that. We can do plane types as well. We can do the pile and pile tip elements, plane types, and we can also look at all the shells, plane stress, gauging shell, plane strain. We can even look at the geogrids as well. And for solid types, we've got a variety of different solids you can have within the software. And we can even do all the others as well. And we've got different element types for the point springs, matrix springs, and the interface for the liner surface and the soil structure interaction. We can look at the shell interface and the connection between, say, galleries and contact between. You can see the interaction between different shell elements such as steel cast iron segments of a tunnel. We can look at the elastic links, and we can also look at the geogrid elements as well. So GTS provides 16 material models, and you can see them below. And we can also do the Mehiculum, von Smith, Ducker, Prager, and you can see an array of different material models on the screen. We can even do the undrained behaviour for the effective stiffness and the effective strength for undrained A, B and C. Different loads and boundary conditions here. So on this slide it's just showing you different loads. So as you can see, there are a variety of different loads you can place on a structure. So just going down through, so you've got self-weight, force moments, prescribed displacements, pressure and pore water pressure loads. Then we can even do the dynamic seismic loads for data generation, response spectrum analysis data as well, including various design spectrum data, and that is to the Eurocode. And we do the time history analysis data as well. So all loads can be applied both to the finite element and also geometry. So for the time history analysis, then such as moving loads like train loads and blasting, the program automatically generates the time forcing function for those situations. So we've got an array of different boundary conditions as well. So such as supports, constrained, nodal head, nodal flux, surface flux, seepage. You can see them all there in front of you. We can look at the unsaturated property functions as well. And we can even look at the different water levels of seepage boundary functions, drainage conditions and everything like that. So all the boundary conditions can be applied to both the finite elements and the geometry. So model wizards for simple and regular type 3D tunnel models. The tunnel modelling wizard automatically generates full analysis data, mesh, loads, boundary conditions and construction stages from the user-defined parameters. So also with the model wizard as well, you can actually do data transfer. So say that you've actually created a template that you wish to model, and one of your colleagues in another office also wants to model exactly the same template, then you can share that model file. So we can do the modelling of ground and meshes. So that's the complete model generated by the wizard. So that is the cores plus the shotcrete and the rock bolts all been created. You can also look at the stress and simulate the results through the different construction stages. We've got the Anchor Modeling Wizard. So NX provides Anchor Modeling Wizard for automatic generation of 2D and 3D anchors using the input of material sections, and we can also look at the grouted and ungrouted lengths. So just looking at the different analysis options and the solver, so NX has a 64-bit solver to allow for fast analysis runtime for your complex projects. You can also increase the number of processors, so it will take a full advantage of those. It can also take advantage of the GPU chip to enhance analysis speed in conjunction with the CPU cores on the computer. So we've got different solver types with multifrontal, dense, AMG and eigenvalue. So for the element formulation, before message generation you can choose the element formulation based on expected element behavior. By default, standard formulations with typical element behavior and integration points is activated, but you can switch to hybrid or reduce formulation with lesser number of integration points for faster calculations. Initial stress conditions can be activated using the K-naught procedure, where horizontal effective stresses are calculated from vertical effective stresses. You can also model the effects of partially saturated soil and limit negative pore water pressures. So just the nonlinear stiffness update. So when Solver performs iterations, you can also choose how the stiffness will be updated at each load step. You can either use the constant stiffness or secant stiffness or tangent stiffness using the Newton-Raphson methods. Along with stiffness update scheme, you can choose incremental procedures such as line search or arc length control to achieve stable convergence. So in short, all the analysis options are there so that you can analyze complex material behavior and load conditions with the good numerical accuracy. So now going back into the model. So just some of the different analysis cases. So different views again. So just go into the analysis. So we've got just the mesh highlighted. We can look at all the different loads and different boundary conditions. So those are the boundary conditions around the outside. And we can look at the different surface loads as well. So there you see the actual loads, and we can actually click on the loads and just edit them as well. So there you go, just a quick edit, and we can change the value. Let's give it a quick 100. We can just preview that in the screen. It'll show the loads up. So we can look at the different construction stages and go into them. So go through the foundation. So this is the dialog box for the control of the construction stages. So as you can see, you've got the mesh set, the activated data and the deactivated data. So it's just a simple case of dragging and dropping it across. It will attach to the model as well as you go through the construction stages, so you get that visualization just to make sure you're picking the correct elements and the correct conditions. So sorry, just to go through the structural arrangement, as you see the foundation and the abutment coming up, and then the embankment going in behind. So one of the robust features of NX is also you can look at different construction sequences. So not only the first one was one without piles, and the second one is with piles. So there's the excavation being carried out, the structural arrangement being added with the piles and everything like that. You can see the piles in the active data, which I'm hovering my mouse over now. And you can also look at the embankment being built up. Exactly the same, but just you can do it with different construction sequences. So if it's going to be varied, you're not sure what the actual feasibility is going to be carried out in the study, so you can just switch between the two and the analysis is a lot faster. So just going back to the presentation, so that's just a brief snapshot. So look at the post-processing. So here you have the the contour plots, and everything comes up in the works tree, and you've got the results tables and also the extraction of results in the graphics and the Excel. We can look at different stress analysis, stress for soil, the shotcrete and the rock bolts. You can also look at the seepage as well and the strain. So just different contour plot types. So just contours with mesh, contours with ISO lines, and you can visualize it on a mesh basis and just manipulate it. So we can look at the real deformation as well of the soil, so you can look at the wireframe and then how much is deformed over a period of time. Now we can animate, so here you see the construction sequence being carried out for a tunnel excavation or a sequential tunnel excavation. We can do splices through the ground, a multitude of different angles. We do the clipping plots, so we can look at the curved as well. So we can also look at multiple clipping planes. So we can detach mesh sets by dragging the mouse, so just by lifting them off. So we can do the results extraction through the construction stages at different locations at different stages. We can look at the settlement profiles as well, so we can also look at the graphical representations and look at the tables. Look at different clipping planes and on-curve diagrams. So we can do the results extraction with the on-curve diagram and the graphical representations. We could do the actual forces and the member forces for the moments in, say, the shotcrete or the tunnel linings, also for the rock bolts, and we can even do the 3D shotcrete. So we can extract the continuous results for shell elements around the outside. So we can do probes and different result tags as well at any point or for any element or any mesh or any node. We can also do a fly through. We can look at the isosurfaces as well, and there's different isosurface plots in results extraction and everything like that. So we can mirror plots as well, so say that we've got one tunnel, we want to make it into a twin tunnel and have a connecting gallery. We can do that just by mirroring the actual model. We can look at hybrid plots and vectors and vector plots and contour plots. We can do the seepage flow and the vector plots for the analysis. We can also do the seepage through different nodals as well and check the flow quantity at the arbitrary planes and by selecting nodes. We can set where we want the range, formatting it so that we can actually look at the legend and make sure that we've got our top range and our bottom range and get everything in between. Make it an easy to use tool. So now I'm just going to take you back to the model and just show you some of this post-processing activity. So just go into the post-processing mode and just look at some of the results. So just look at the displacements first and the totals. So now it's displayed, and we can look through that through the construction stages, and we just press. So as you can see the heave at the bottom there, and you can see the construction stages being built up. So there's the foundation and the embankment being built. You can look at the real deformation. So there's the deformed and the undeformed. And we can also visualize it where you've got a deformed and you've got it so that you've actually got the wireframe and the deformed, so they can see the actual deformation that's being carried out. So there's the undeformed, and you've even got your legend there just giving you the total deformation as it happens. So we just do the probe results. So I just want to click on a few places here and show you how you can get a table from it as well. So there's the different probe results. You can do it through the actual different construction stages, and you can visually see them as they change. So we can extract those as well, and we can extract the results from different locations. So we've got a few actually on the screen, but we'll just make a couple more. And we can actually get that into a table format, so that you can visually see the table coming out and actually where the tag is, and we can do the graphical representation as well. Now just looking at the on-curve diagrams as well, to show you how you can just do a simple cutting plane, just go cut through the object of where you want the actual plane to be. There's 2 points. You can see a replay as well, we can just apply it so they can see the on-curve diagram. You can visualize it from different points. So now we'll just go to the 3D report and just create it. So we're just going to select a few at random, so the model and the mesh, and we can look at the different results. So you can select the multitude of different results. So this is a 3D report, just about to show you now. So I'm just going to click on a few more just so I can highlight them. Okay, and I'm just going to bring it across. So rather than creating it, just to bring it straight across for you. So this is a 3D report. So you see you actually have the 3D model within the working space. You can manipulate it and move it around. You can look at different layers as well, so you can see the front. So you can do different views and look at it from the left, and you can manipulate it. So just look at the back, look at the isometric. You can look at different solids, you can look at all the different wireframes, exactly the same you can in the actual program itself. So you can look at the different hide views, and you can hide different things as well, so you can actually manipulate it in that sense for all of the geometry. So you've got exactly the same tools that you've got in GTS NX, but you've got them actually within the 3D report. So now I'm just going to show you some the results. So now just go to some of the results as well. So different construction stages. So bear with me a second. Computer's got some processes going on. So these are the loads and boundary conditions. So that's the next step. You can look at the different tools. You've got like different clipping planes and everything like that. So just to isolate things. So just looking at the results. So you can extract any result you've actually see fit. So we can look at through the construction stages. So you see the excavation, and also the embankment being created there. You can look at the different wireframe options and everything like that. So as you see, visualization is excellent. So as long as you've got Adobe 11, then you can actually transfer this to other people so they can visualize it. You can do clipping planes through it, and you can cut through the solid and through the mesh. You see that. I just wanted to give you a quick overview. So as you see, you can look straight through the actual mesh itself into the superstructure underneath, and look at all the different views as well. So just the legend down the side. So just go back into the presentation and just close with some of the project applications. So just to shut everything down, get out of the way. So just want to briefly flick through the project application. So sequential excavations of tunnels in fractured rock. So you see complex geometries there. Tunnel connected to vertical shafts and underground structures. So a project image just illustrating that, and then you've obviously got the shaft with all the rock bolts and everything. So the King's Cross station with the sprayed concrete lining. The construction stages going on there. Excavation adjacent to existing underground tunnels, so large excavations being carried out, and we can actually see the effects of vibration in trains as well. Helsinki underground western expansion with 7 different sections. Temporary railway bridges with shored wall excavations there, and you can see the temporary supports of the structure and the construction stages being carried out, and the effects on the actual temporary supports. So underground paths and foundation supports here, with the temporary supports you can see going across, and those are all the construction stages as well. The Odeon Tower, where you can see the construction stage analysis being carried out with temporary supports to the structure. 3D blasting and vibration analysis being carried out in tunnels for the excavation, stress-seepage analysis for tunnels in fault zones, and with the rock bolts and everything, you can see at the bottom images there, and the pore water pressures, abutment foundation design by construction stage analysis, Abu Dhabi Tower, with the superstructure underneath and the construction stage analysis being carried out on the podium, and the basement levels, and also the superstructure piles and rafts. As you can see, we've got all the bending moment diagrams, vertical strains, the rock layers, and the cuts and the settlements. The Trans-Hudson Express going under the Hudson River, and that was midas GTS NX. So at the moment it's a new experience of geotechnical analysis systems. We are providing a free service at the moment, a free trial, which is fully supported. So if you do want to try it, then please obviously just email in or call in, and you can also visit us at the address there on the screen, but we will send you that link as well. And you can also see other YouTube content. If you wish to contact us, there's a few of the details, and there's our address. And that's it. Thank you for coming in and tuning into this webinar. It's been hopefully very informative for you, and you'll be able to see the advantages of NX for your projects in practice. So, and remember, we will work with you on live projects and everything like that. But if you want to tune in for other webinars, then please do. And we did on the eShot, then we did provide you with a list in the email. And next time we will actually provide it so you can register for all those post haste. But if you do want us to register you, just please send in your name and your email address, and then we'll make sure you're on there. And that's fantastic. Thank you for your time.